Welcome Year 11 to this video in the exam technique series on electrolysis. I will be looking at two practice questions or past paper questions that you're going to practice doing yourself so that you can see if you can put some of the exam question approach techniques into practice yourself in preparation for the exams. Please remember to subscribe, like, and share this video so that this channel can continue to grow. It is very much appreciated. So just like in previous videos, I do have on the screen the 4-step process in my exam question approach method. And if you're not familiar with this, I would strongly suggest that you pause the video and read through and make sure that you follow these steps whenever you're answering any exam question. And remember, this doesn't just have to apply to just science, it can apply to any subject. The other thing I would say is that if you are familiar with this, that's fine, you can move ahead. The other thing to note is I have done a video, an interactive revision tool to remember the required practical on electrolysis, and you can find the link of that here. Okay, so question 1. This question is about the extraction of aluminium. An aluminium atom is represented as, and there's an image of the aluminium atom in the periodic table. It says, give the number of electrons and neutrons in the aluminium atom. So you have to recall that information from earlier on in the C1 module. So you can pause the video here and write your answer. Right, next part says aluminium is extracted by the electrolysis of a molten mixture of aluminium oxide and cryolite. So straight away, there's a lot of keywords here. We're talking about extraction, we're talking about electrolysis, we're talking about molten rather than aqueous mixture, and they've mentioned something called cryolite. So if you're familiar with the aluminium oxide electrolysis, this should not be a surprise. The diagram below shows the cell used for the electrolysis. So again, look at the diagram carefully. You've got the metal wire. Why is it metallic? You've got the positive electrode. You've got the negative electrode. You've got the molten mixture of aluminium oxide and cryolite. Why is cryolite added to aluminium oxide? And then you've got molten aluminium being separated at the bottom, which is what you want. Part B, aluminium is produced by the reduction. What does the word reduction mean? Can you remember? So the reduction of aluminium oxide. And surprise, surprise, what is meant by the term reduction? So I'm going to ask you to pause the video here so that you can answer the question. Part C. Oxygen is formed at the positive carbon electrodes. Explain why the positive carbon electrodes must be continually replaced. So you've got to think about this. There was a reason you would have been taught this. Try and see if you can recall this. And you've got 3 minutes. So I suggest you pause the video now so that you can answer. Okay, moving on to question D. A substance conducts electricity because of free-moving charged particles. What are the free-moving charged particles in a carbon electrode made from graphite, a molten mixture of aluminium oxide and cryolite, and metal wire? So they're talking about 3 different types of materials that can conduct. Carbon electrode, so that is made from graphite, which is a giant covalent substance, one of the only giant covalent substances that can conduct electricity. Then you've got molten mixture of aluminium oxide. Aluminium oxide is an ion. And then you've got a metal wire, which has got metallic structure, giant metallic structure. So you've got to think about why there are charged particles in those 3 substances. And again, you've got 3 minutes because it's 3 marks. So you can pause the video now to write your answer. Okay, now you've finished your answer, you can actually mark your answers with the mark schemes on the screen. So you might want to pause it so you can read through carefully. Now that you've done that, I've also got the examiner's report on the screen. So you can have a look at the examiner's report and see where students, how students did the questions when the questions were released live in the past. So you can see how well you've done compared to the previous students. Now, question 2. A student investigated the electrolysis of potassium chloride solution. The diagram below shows the apparatus used. So again, look at the apparatus. You can see that there's more gas, hydrogen gas than chlorine gas. It looks like it's twice as much. You've got potassium chloride solution. So what ions must be present? It's a solution, so it must have something else added apart from just potassium and chloride ions. You've got inert electrodes, so they must be made out of graphite, for example. And then part A says, why are inert electrodes used? So what does the word inert actually mean? So you can pause the video now so you can answer the question. And then it says the student measured the volume of gas collected at each electrode for 25 minutes. The graph below shows the results. So what you can see is the time in minutes on the x-axis and the volume of gas collected in centimeter cubed on the y-axis. You can see that the hydrogen line there's a lot more hydrogen gas than chlorine, as we realize from the diagram. And you can see that when there is 25 when there's 20 after 25 minutes, there's just about 6.8, I think it is, centimeter cubed of chlorine, but there is about 9 centimeter cubed of hydrogen gas. So it's a little bit more. So I would look at that ratio a lot closely. And then it says part B, compare the rate of collection of hydrogen and chlorine. Give one similarity and one difference in the rate of collection of the gases. So look at the graph, look at the similarities, where there are parallels, where there aren't, and so on. So you've got 2 minutes, 2 marks. You can pause the video now and answer the question. And then part C, the rate of production of hydrogen and chlorine at the electrodes is the same. Explain how the graph on the graph above shows that chlorine is more soluble than hydrogen. Explain why hydrogen gas is produced at the negative electrode in the electrolysis of potassium chloride solution. Okay. And then for part E, it says write the half equation for the production of chlorine gas at the positive electrode. So there's a lot of information here. You need to annotate each part. And again, we've got a total of 8 marks. So it's 8 minutes. I suggest you pause the video now and try and answer those questions. Okay, so now that you have answered all those questions, I've got the mark scheme on the board, or on the screen, sorry. I'm so used to saying the board as a teacher. So you got the mark scheme available. Unfortunately, this was not, I don't have access to the examiner's report for this specific question, but you can see the mark scheme and you can see where you've, got the right answer, or if you've got the wrong answer, and where you need to do some more revision in preparation for your exam. Hopefully this has been useful for you. I have put a description information in the description box on how you can access more past paper questions. And at this point, that's really going to help you get used to what the examiner's looking for, because you're going to be looking at the mark schemes regularly, looking at the typical types of questions and a typical type of answers that they're looking for. So once again, I'm going to ask that you subscribe, like, and share this video so that I can grow this channel even more. And I wish you all the best and good luck for your exams. Bye.